All right, so in the last video, we learned how to find the zeros of a polynomial, and today what we're going to be doing is finding out how to graph these polynomials using those zeros. So we're not going to sketch exact graphs. It doesn't none of these are going to be exact, but they're just going to be rough graphs, and we can do a rough graph pretty easy. So I'll just get into it. My first polynomial here is f of x equals x to the third plus x squared minus 8x minus 12. And the first thing is asking me, is it even or odd? So the way to tell if it's even or odd is pretty simple. I'll actually use a highlighter. So yeah, it's just the degree. Oop, that is huge. Okay, yeah, we'll go with like that one. The degree of the highest exponent. So highest exponent here is 3. So since that 3 is the highest exponent and 3 is an odd number, that makes this an odd polynomial. Next, it's asking, is it positive or negative? So negative x to the third, or it's positive x to the third plus x squared minus 8x minus 12. This is positive x to the third. It's a positive polynomial. And I believe I've showed you guys this little diagram that I've had to draw before. So I'm going to sketch it real quick. Then I have positive, negative, we'll say even or odd. So if a polynomial is positive and even, that means its end behavior is going to look like two up arrows. If a polynomial is positive and odd, its end behavior is going to look like a down arrow and then an up arrow. If a polynomial is negative and even, it's going to be two down arrows. And if a polynomial is negative and odd, it's going to be up, then down. So since this one is odd and positive, that means we are doing the down, then up. So yeah, where did this come from? Oop. Okay, so there we go. Since it is odd and positive, the end behavior is going to look like that. And we can just determine that just by telling if it's even or odd and then positive or negative. Pretty simple. So the number of possible zeros. Well, when we were doing the stuff on the video from the other day, it was the number of zeros that there were, or the number of solutions we were looking for, was the degree. And that's the same thing here. So that 3 is the number of possible zeros. So I got 3 possible zeros. Okay. Yeah, it's x to the third, so there are 3 possible zeros. My possible rational zeros. So I could go ahead and list, actually, I actually will, yeah. I'm actually going to make this a little smaller too, so I can have more space. So I have my p could be, well, it's all factors of the constant. And here the constant is this negative 12. So all factors of negative 12. Positive or negative 1. Positive or negative 2. Positive or negative 3. Positive or negative 4. Positive or negative 6. And positive or negative 12. Those are all factors of negative 12. And then I have q. Since it's just x to the third, 1x to the third, that means I'm taking the factors of 1. And the factors of 1 are just 1. So positive or negative 1. And then I need to find my possible rational zeros. So the possible rational zeros are going to be p over q. So I have, p, z, p, r, z, possible rational zeros is going to be, well, I'll take the 1 in p divided by the 1 in q. It's positive or negative 1. Since I'm just dividing all these by 1 in q, it's just going to look the exact same as my list for p. So positive or negative 2, positive or negative 3, positive or negative 4, positive or negative 6, and positive or negative 12. Those are my possible rational zeros. So since there's 6 of them, but they're all positive or negative, there's 12 possible rational zeros here. Okay. So next, what are we going to do? Oh, then we actually determine the zeros. That's why there's this big old space here for part F to determine the zeros. And we're going to do that using synthetic division. So let's see, this is x to the third minus x squared, or plus x squared minus 8x minus 12. So I have 1x to the third. Yeah, I want to make 1x to the third, 1x squared minus 8x minus 12. And I'm going to, the first list, or no, first number on my list of possible rational zeros is 1. So I'm testing 1. When I test 1, bring down the first value. Sorry, I forgot to give it that underline. So I bring down the first value, gives me 1. The 1 in the box times the 1 down there is positive 1. 1 plus 1 is 2. The 1 in the box times 2 is positive 2. Negative 8 plus 2 is negative 6. The 1 in the box times negative 6 is negative 6. Negative 12 minus 6 is negative 18. So since that last number there, that negative 18, that's not 0, that means that 1 is not a 0 of this polynomial. Okay, next one we'll test is negative 1, because that's next on my list of possible rational zeros. And I'm going to line up my same coefficients. I got 1, 1, negative 8, negative 12. Oop, okay. Bring down the 1. So negative 1 times 1 is negative 1. 1 minus 1 is 0. Negative 1 times 0 is 0. Negative 8 plus 0 is negative 8. And then negative 1 times negative 8 is positive 8. And negative 12 plus 8 is negative 4. So negative 4, that last number, isn't 0, which means that negative 1 is not a 0. Next number I will be testing will be 2, positive 2. So I got my 2, and I got 1, 1, negative 8, negative 12. Bring down the 1. Okay, so I got 2 times 1 is 2. 1 plus 2 is 3. 2 times 3 is 6. Negative 8 plus 6 is negative 2. And then 2 times negative 2 is negative 4. And negative 12 minus 4 is negative 16. And again, since that negative 16, that's not 0, it should be 0, that means 2 isn't a 0. Next number we're testing, negative 2. We got 1, 1, negative 8, negative 12. So bring down the 1. So negative 2 times 1 is negative 2. 1 minus 2 is negative 1. Negative 2 times negative 1 is positive 2. Negative 8 plus 2 is negative 6. And negative 2 times negative 6 is positive 12. And then negative 12 plus 12 is 0. So since that last number there is 0, that means my first 0 on this polynomial is negative 2. So my first 0, I'll just list negative 2 right there. And I know that I'm looking for 2 more because there are 3. So since I'm looking for 2 more zeros, I'm taking these coefficients here and writing myself a new polynomial. I'll write it in a different color. Like this. That's the same color. No, it's not, but it's a similar one. Okay. Yeah, we'll go with orange. Okay, so since I'm looking for 2 more zeros, I have my numbers here, my 1, my negative 1, and my negative 6. So I have 1x to the second, since I'm looking for 2 more zeros, minus x, or 1x, and then minus 6. So this is my new polynomial, and this polynomial is a quadratic. I wish that orange wasn't as close to the color I was using before, but this polynomial is a quadratic, so I can factor it. So I am looking with this quadratic for 2 numbers that are going to multiply to be negative 6, and they're going to add to be negative 1. two numbers that multiply to be negative 6 but add to be negative 1. That is going to be negative 3 and 2. So x squared minus 3x plus 2x minus 6. Then I group x squared minus 3x, the GCF is going to be x. And I'm left with x minus 3. And then 2x and negative 6, I pull out a 2. And I'm left with x minus 3, which leaves me with x plus 2 times x minus 3. And just like before, we have to set that equal to 0. So we got to set each factor independently equal to 0. So x plus 2 equals 0, and x minus 3 equals 0. And if x plus 2 equals 0, subtract 2 from both sides, x equals negative 2. Subtract, or add 3 to both sides, x equals 3. So I got negative 2 and 3. So my other two zeros are negative 2 and 3. So here comes the next part. Actually, we'll look at this part G down here first. So G, the multiplicity. So the multiplicity, that's the word we haven't seen before. That just means how many times is a certain number going to repeat itself. So this one, we have negative 2, and 3. Since there's two negative 2's, this has a multiplicity of 2 because there's 2 of them. And then since the number that it's being multiplied by is negative 2, that means 2, there's a multiplicity of 2 at negative 2. That means 2 of my zeros are negative 2. If none of the zeros repeated themselves, you would just say multiplicity none, because it would just be 1 at everything. So there's no reason to list the multiplicity. So if you say if none of the zeros repeat themselves, there's no multiplicity. So this one has a multiplicity of 2 at negative 2. And sometimes there can be more than one thing that you're going to have to say for multiplicity. Sometimes the zeros will repeat themselves. Anyways, back to this. So we got negative 2 and 3 are zeros. So on my x-axis, I'm going to put zeros at negative 2 and 3. And then what I'm going to do is, the other thing that I already knew was my end behavior. My end behavior had a down arrow, then an up arrow. So down on the left, up on the right. Now, the last thing I need to do is I need to make a graph that is going to go through, or is going to start on this arrow. It's going to go through these 2 points somehow and then end up there. What we have to do here is rely on the multiplicity to determine whether it's going through or bouncing at a certain point. So, since negative 2 had a multiplicity of 2, if a number has an even numbered multiplicity, so since 2 is an even number, negative 2 has an even multiplicity. If a number has an even multiplicity, it bounces off, meaning that this line is going to start here, it's going to start here, and then it's going to bounce off. And 3, that was my other 0, has an odd number multiplicity because it has a multiplicity of 1. So if it has an odd numbered multiplicity, it goes through. So it goes through because 3 is only a 0 once. And it can't go through the axis at any points other than those zeros. If you find it going through like a point that you haven't found, then you're not graphing it correctly. It can only go through at these numbers that you found, the zeros. Which means, or it might also bounce off, you don't know. Anyways, that means that the graph of, what was our original polynomial? X to the third plus x squared minus 8x minus 12 roughly is going to look like that. That's a rough sketch of the graph of x to the third plus x squared minus 8x minus 12. And when we say a rough sketch, we mean what's the end behavior looking like? Where are the zeros? It's a bound center going through the zeros. That's all. Those are the important parts of a graph. So this packet, it's supposed to be a packet, but I'm giving it to you online, so it's not, has 10 questions. By the way, number 10 here is a challenge. So you don't have to do number 10, but you can if you want to. But we have all these other problems on here. A lot of them just have 1x, or the q value when you do the p over q is going to be 1, so you don't have to worry about too many fractions. Like number 5 is one where you're going to have fractions because it has a negative 6 out front. Number 4 has fractions because they have a 2 out front, but like 3 has a 1 or negative 1. 2 has a 1. So yeah. Yeah, we're going to go to the other problem that I want to do together is number 7. And we're also going to look at another one, like just glance at it before you do your own thing. Okay, so number 7, we're graphing f of x equals negative 2x to the fourth plus 11x to the third minus 17x squared plus 6x. So on this one, is it even or odd? Well, we have negative 2x to the fourth, and since 4 is an even number, it's an even polynomial. And since it is negative 2x to the fourth, it is a negative polynomial. Which means, I'm just going to go back up and copy paste that thing. Okay. Oh yeah, okay. There it is. Okay. So since it is even and negative, that means my end behavior is going to look like 2 down arrows. Okay. Number of possible zeros. Well, that's just the degree. Since the highest degree is 4, there are 4 possible zeros. I'm looking for 4 answers here. And the possible rational zeros, this is where things get tricky. This is why I wanted to do number 7, because to do the possible rational zeros, the first thing you have to do is p over q. And p is the factors of the constant. But there is no constant on this, because the last number there on the end is 6x. So this is basically 6x plus 0. But I can't find the factors of 0. So what I have to do, I'm just going to look at my polynomial without the 0 there on the end. Looking at this, there's something I can factor out of all of these terms. So between negative 2x to the fourth and 11x to the third and negative 17x squared and 6x, all of these terms have x inside them, which means I'm going to go ahead and rewrite this as x parentheses negative 2x to the third plus 11x squared minus 17x plus 6. And if I just distribute that x back in, I get back to this. So I came up with a new polynomial here. Negative 2x to the third plus 11x squared minus 17x plus 6. And this polynomial has 3 zeros, which means 3 of my zeros lie within here. So my fourth 0 comes from this x here. So if I set that equal to 0, that means my first 0 is x equals 0. Which means down here at f, I'm just going to list 0 from the beginning. So 0 is 1, and then I'm going to use this polynomial to find the other 3. So let's see my possible rational zeros. I'm going to list my p and my q. And by the way, you don't have to list p and q every time. I just like to so I can visualize, like, oh, I'm dividing this number by this number, and I'm dividing this number by this number. But, you don't have to. So p, and I'm using a new polynomial to do this. So p is the factors of 6, q is going to be the factors of negative 2. So p is going to be positive or negative 1, positive or negative 2, positive or negative 3, and positive or negative 6, because those are the factors of 6. Then I have q, which it's the factors of negative 2. So I got positive or negative 1 and positive or negative 2, which means my possible rational zeros are going to be, well, I can take the 1 from the p divided by the 1 from the q, which gives me positive or negative 1. I got the 2 from the p divided by the 1 from the q, positive or negative 2. 3 from p divided by 1 from q, it's positive or negative 3. And 6 from p divided by 1 from q is positive or negative 6. And then I have to do 1 from p divided by 2 from q, it's positive or negative 1/2. 2 from p divided by 2 from q, well, 2 over 2 is 1, and 1 is already on my list. 3 from p divided by 2 from q is positive or negative 3/2. And then 6 from p over 2 from q is just going to be 3, and 3 is already on my list. So that means the possible rational zeros here are 1, 2, 3, 6, 1/2, and 3/2. So we need to determine which ones it actually is. I'll make this a little bigger. Okay, so I'm using my new polynomial that I came up with. So that negative 2x to the third plus 11x squared minus 17x plus 6. And I'm just going to start testing some of these possible rational zeros. So the first one is positive 1. And I believe it was negative 2, 11, negative 17, and 6. Bring down the negative 2. So 1 times negative 2 is going to be negative 2. 11 minus 2 is 9. 1 times 9 is 9. Negative 17 plus 9 is negative 8. 1 times negative 8 is negative 8. And 6 minus 8 is negative 2. So since that negative 2 isn't 0, that means 1 isn't a 0. Next number I'll test is negative 1. So I got negative 2, 11, negative 17, 6. Bring down the negative 2. So negative 1 times negative 2 is positive 2. 11 plus 2 is 13. Negative 1 times 13 is negative 13. Negative 17 minus 13 is negative 30. And then I have negative 1 times negative 30 is positive 30. 6 plus 30 is 36. So since 36 isn't 0, that means negative 1 is not a 0 of this polynomial. Next one I'll do is 2. So I got negative 2, 11, negative 17, 6. And in case you forgot, this 1, this negative 1, this 2, these are coming from my list of possible rational zeros that I just listed in part E there. So let's see, I'm bringing down that negative 2. So 2 times negative 2 is negative 4. 11 minus 4 is 7. 2 times 7 is 14. Negative 17 plus 14 is negative 3. 2 times negative 3 is negative 6. And 6 minus 6 is 0. So since that last number there on the end is 0, 2 is a 0 of this polynomial. So I'm going to put 2 up there at the top with 0. Okay. Now I'm looking for 2 more zeros. So I'm going to take these 3 numbers here, that negative 2, that 7, and that negative 3, and I'm going to rewrite this into my new polynomial. And I'm going to have negative 2x to the second power, or squared, because there's 2 more zeros that I'm looking for, plus 7x minus 3. And I'm finding the zeros of this quadratic. It is a quadratic because it's x squared, and since it's a quadratic, I can factor it. So now that it's down to this point, I can just find the factors of it. So I want negative 2 times negative 3 is positive 6. So I want two numbers that multiply to be 6, and they add to be 7. So those two numbers are going to be 6 and 1. So negative 2x squared plus 6x plus 1x minus 3. And then I group. Let's see. So between negative 2x squared and 6x, I'm going to pull out a negative 2x. And I'm left with x minus 3. And between x and negative 3, I can't pull out any GCF, but I have to pull something out. So I'm going to pull out 1, x minus 3, which means the two factors of this polynomial are going to be negative 2x plus 1 and x minus 3. And to find the zeros, just set both equal to 0. So this means I got negative 2x plus 1 equals 0, and x minus 3 equals 0. If x minus 3 equals 0, add 3 to both sides, x equals 3. If negative 2x plus 1 equals 0, subtract 1 from both sides, so I got negative 2x equals negative 1. And then I'm going to divide both sides by negative 2, so x equals positive 1/2, which means my other two zeros were 3 and 1/2. Okay, so my 4 zeros, because I said I was looking for 4, because the degree was 4, are going to be 0, 2, 3, and 1/2. So I'm going to plot those 4 numbers on my number line. So I got 0, 2, 3, and 1/2. And I know they're all very close together. It's fine. And I said the end behavior of this polynomial is going to be 2 down arrows, which means I'm going to have down on the left as well as down on the right. So, oh, my multiplicity down at the bottom. Okay, so my 4 zeros, I had 0, 2, 3, and 1/2. None of these numbers are repeated because it's not 2 twice, it's not 3 twice, it's not 1/2 twice, and it's not 0 twice, which means my multiplicity, since none of them are repeated more than once, we say that there is none. So there's nothing significant. It's just each 0 occurs once. And since there's just a multiplicity of 1 at each of these points, that means it is going through all 4 of these points. So we're going to start with our polynomial. We're coming this way towards that 0. It doesn't really matter if it looks wonky as long as it hits 0. So we want it to go through 0. And we want to go through 1/2. And we want to go through 2 and back through 3. And then connect. So I made something that looks like that. It doesn't have to be pretty. It just has to be a polynomial that has the end behavior looking right, the 4 zeros, correct spots, and is going through or bouncing off those 4 zeros. Well, it's going through all 4 of them. So there we go. That is a rough sketch, a very rough sketch of the graph of negative 2x to the 4th plus 11x to the 3rd minus 17x squared plus 6x. And by the way, the reason I did number 7 is because of that 0 there, because I knew it would throw a lot of people off. So yeah, the reason I did this is because that 0, and there aren't any more in this assignment that have that 0 is 0. So you don't have to worry about factoring out an x on any of the other problems. I just wanted to show it to you because I knew there would be a lot of questions. The last one I want to help you set up before letting y'all do your own thing is number 9. So number 9, when I do my polynomial, or my synthetic division on this one, so when you do synthetic division on this one, you're going to have some number that you're dividing it by. And then we got, let's say, 1x to the 4th, and then we're looking for x to the 3rd. But it goes to the x squared, x to the 2nd. Since it's not x to the 3rd, that means that we have 0 x to the third. You're not going to say 1, -5, 4, because those aren't the coefficients. There's also a 0. And then we have minus 5 x squared. And then once again, working for x, there is no just plain x. So it's 0 and 4. So when you do your synthetic division on this problem, you're going to set it up with 1, 0, -5, 0, 4. And then you're going to find your possible rational zeros. And since this is degree 4, there are going to be 4 of them that you're looking for. So you're going to use these numbers and solve. All right, so other than that, it should be okay. You should be able to do your synthetic division just fine. Sketch a graph, just know when it hits 0, when it bounces, when it goes through, know what the end behavior looks like. List those possible rational zeros, which I taught you how to do in the last video. Even or odd, I think that was like unit 1 that we learned about even or odd and positive or negative. And multiplicity, I know that's new. Multiplicity, yeah, how many times does the certain number occur? For this problem, -2 occurred twice, so we said it had a multiplicity of 2, because it was twice, at -2, because -2 is the number that occurred twice. And I believe that's it.